Next is we need to study that is the types of DC motor. Okay, चाहे वो DC motor हो or either it would be DC generator, thus there is a difference in the direction. Let's see how. What are the types of DC motor? One motor there is DC series motor. Okay, one motor there is a DC shunt motor. There is one motor that is separately excited motor, separately excited DC motor, and another last motor is compound wound motor. Compound wound motor. Okay, it can be generator also, DC generator, and it can be motor also. So what is in the series motor? As its name suggests, series. So we are having mainly two important things. One is the armature and one is the winding. So this in this armature and field windings are connected in series. Let us see how it looks like. DC series. Okay, so we are having one armature is the main part. Armature is represented by like this. Okay, this is the armature, and one is the field winding. Field winding, you know, na, that is used for making magnetic field. Remember in the construction I told you, we are having magnet like this, and we use it these windings, and this field windings is used to make magnetic field. So this one is the field winding. So there are two main important part. One is the field winding that is used for making magnetic field, one is the armature. In the DC series motor, both are connected in series only. Okay, so if it is the case of motor, then in that case current is moving inside, right? If in then in this case current is moving inside. If it is the case of generator, I am drawing the same diagram for the generator, that is field winding and armature both are connected in series. So if it is the case of motor generator, the current is moving outside. Why? You know that in motor you are providing electrical energy, right? So the in current would move inside only, and here is the voltage we will give plus minus voltage. But in the generator we are getting electrical energy, right? Because a generator converts mechanical energy into the electrical energy, so we are getting electrical energy. So that's why current direction is like this. Again, this is positive, negative, V I. Okay, so this is the current flowing in the series, so we denote it by ISC. This is the current flowing in the armature, so we denote it by IA. So in this case all are series, all are connected in series. So can we write down I is equal to ISC is equal to IA? We can write down this thing now. I is equal to ISC is equal to IA. So in this case also, here the current is moving outside from the armature current, here also the current moving from the series, so it would be I is equal to ISC is equal to IA. This is the case of DC series motor or generator. Okay, understood? Next kind of motor is the DC shunt motor. What does shunt mean? Shunt means the parallel, right? Shunt means which are connected in parallel. So again we are having two things. One is the field winding and one is the armature, right? These two connected are in parallel. Again we'll draw for the generator as well as for the motor. Then we'll see what is the difference between these two. Now again there is a supply plus minus V voltage, plus minus V voltage. This is the case of suppose motor, so the current is moving inside. This is the case of generator, so the current is moving outside, right? In motor current is moving inside, that is denoted by armature current, and in this field winding current is ISH, because it is current connected shunt, that's why they have denoted by ISH. Okay, in this also field winding, uh, always you know that to make a magnet we need current now. So this in this current is moving inside the field winding, that is again ISH. But this is the case of generator, so armature generator gives armature current, so that is IA. You can see that which directions are different. This one direction is different and this one direction is different, because in the case of motor armature is taking current, so it is moving inside, but in case of generator armature is giving current, so it is moving outside, right? So in case of motor we need current, motor need current, so it is moving inside the motor. But in generator is giving the current, so that's why it is outside. But this one and this one is same. Why? Because in both the cases we need current in the field winding, right? Correct? To make it a temporary magnet. So if we'll apply Kirchhoff current law here, if I'll apply Kirchhoff current law, then in that case, what would be the value? You know na Kirchhoff current law, that incoming current is equal to the sum of outgoing current. So according to this, current I is the incoming current and IA and ISH are the outgoing current. So we can write down I is equal to IA plus ISH. Okay. So in this case, what would be the value? IA is going moving IA ISH plus I. Now tell me, I value would be equal to IA minus ISH. Clear? Any doubt up to here? If I need to calculate IA for this, that is I minus ISH. So we need the value of these armature current and the normal current for the purpose of numerical. So for the purpose of numerical, DC shunt motor is very, very important. Okay, clear this thing? Next is the separately excited motor. Okay. Next is the separately excited DC motor. As its name suggests, separately means we will give different supply to the field winding and we give different supply to the armature. Like this. There is the field winding, then we give different supply to the field winding, that is plus minus V, and there is the armature. We give different supply to the armature. Similarly for the case of generator also, we give different supply to this and we give different supply to this. Okay, so in the case of motor, again we consider it as a motor. The current is moving inside the armature current, so it would be armature current. In the case of generator, the current is moving outside from the armature, so that would be armature current. Okay, in both the cases we need current in the field winding to make it as a temporary magnet. So in this we have denoted by IF. Separately excited DC motor you will not use in the numerical. Clear this thing? Next is the compound wound DC. So as its name suggests, compound means the combination of the series as well as for the shunt. Okay, so we are having again armature we have combined in series first, then we have combined with parallel like this, and again we'll give the voltage supply plus minus V. We can do one thing more, that armature first it is connected in parallel. Okay, then both are connected in series. Now we can draw it like this. Okay, what is the difference between these two? That in this armature first it is connected in series, then both are connected in parallel, right? But in this case armature it is connected in parallel, then both are connected in series. So okay, it looks like a long, so it is known as long shunt compound, and it looks like a short, so it is a short shunt compound. Okay, clear this thing? Okay, so in this you can draw the notation like this is the total current I, this is the total current I, this is the current across shunt ISH, this is across ISC, and this is IA. Okay, similarly you can draw it for this. So these are the four types of motor which would be helpful in numerical, and this can be your question for the theory part as well, that define the different types of DC motor. Understood?